Welcome friends, this is Rishikesh. Today we will start with program design tools. There are mainly three program designing tools: algorithms, flowcharts and pseudocode. Today we will start with algorithms. Let us have a look at what is algorithm. Algorithm is a finite set of instructions for performing a particular task. The instructions are nothing but the statements in simple English language. Here are some characteristics of algorithms. First one is each algorithm is supplied with 0 or more inputs. So algorithm can have 0 as the least input and it can be have as much inputs as it wants. Second one is each algorithm must produce at least one output. So it is necessary that algorithm should produce at least a single output. Each algorithm should have definiteness, that is each instruction must be clear and unambiguous. And the fourth one is each algorithm should have finiteness, that is if we trace out the instructions of an algorithm, then for all the cases the algorithm will terminate after finite number of steps, that is finiteness of the algorithm. Algorithm is basically a sequence of instructions written in simple English language that we have seen, and the algorithm is broadly divided into two sections. The first one is heading section and the second one is body section. The algorithm consists of basic building blocks such as simple statements, and second one is control flow statements. So these two are the basic building blocks. In simple statements, the simple statements consist of assignment statements or input output statements and comment statements. And in control flow statements will be like if and then condition statements, looping statements, that will be in control flow statements which will control the flow of the algorithm. Now let us see how algorithms are written. So here is an example. The question is write an algorithm to find whether the number is even or odd. So we are going to write an algorithm which will determine whether the number is even or odd, and at the last it will give us an output telling whether the number is even or odd. The algorithm is defined in several steps. Here are four steps. The first step in every algorithm is start. In second step we will input number n to determine whether it is even or odd. In second statement we have control flow statements that will determine whether the n, that is input number, is even or odd. Here we have used modulo operator, n modulo 2. If it is equal to 0, that means if n is divided by 2 and the remainder is 0, then we will print that number we have inputted is even, else we will print that the number n is odd number. So this is the third step. In third step we have control flow statements, and the last fourth step is the end step. In every algorithm the last step would be end step. So this is how we write a simple algorithm for any problem we want to solve with the help of computer. Every algorithm is considered as a mirror image of program that we write to solve the problem. Let us see another example. The question is write an algorithm to find the sum of n natural numbers. So we have to find the sum of first n natural numbers here. So in this algorithm the first step would be start. In every algorithm we have seen that the first step is start. Second step would be like input value of n. So we have to input the value of n from the user. In third step we will initialize the value of sum equal to 0. So at the start of the algorithm or the start of the program, the value of sum would be 0. In fourth step we have control flow statements. In fourth step we have used looping statement to calculate the sum. We have also initialized one more variable, that is I. The value of I is initialized at 1, and then we will increase I up to n using looping method, and after each loop we will add that I to the previous sum. So in the first looping scenario, the sum is equal to 0, and when we add I, that is 1, to the sum, then the sum for the next loop would be 1. Now for the second loop, our initial sum is 1 and we have incremented our I to 2. So the next sum will be like 1 plus 2, that is 3. So our sum is increased. This process of looping will continue until we reach the value of I to n, and in the fifth step we will print out the sum that we got at the last of fourth step, and the last step, that is sixth step, would be the end of the algorithm. Let us see one more problem. The problem is write an algorithm to find the Fibonacci series up to less than or equal to 10. So what is Fibonacci? In Fibonacci series sequence, each number is the sum of the two preceding ones. The series will start like 0, 1, then 0 plus 1, that is 1, then 1 plus 1, that is 2, then 1 plus 2, 3, 2 plus 3, 5. So in this way it will proceed. Now we have to write an algorithm to find the series up to less than or equal to 10. So the first step would be start. In second step we would initialize variables. First term, the value of first term would be initialized at 0. Second initialization of variable is second term, the value of second term would be initialized at 1. So we have initialized our first two terms of the series, that is the 0 and 1. In third step we will print first term and second term. In fourth step we have control flow statements. We will repeat some steps until the second term is less than or equal to 10. So the first step we would do is we would initialize one more variable, that is temp. The variable would be equal to second term. Then the second term would be calculated as second term plus first term. So we are calculating the next second term by addition of previous two terms. In the third step we will initialize first term to the temp variable that we have initialized in step 1, and in the last step we will print second term. So these four steps will be repeated until the second term is less than or equal to 10. When our second term exceeds the condition, then we will get out of this loop and we will have the series of Fibonacci numbers up to 10. And the final step we write in algorithm is end step. So this is how we can write an algorithm to find the Fibonacci series up to less than or equal to 10. These are some examples of algorithm writing practice. You can do more practice by writing algorithms for the general problems that we can solve using programming. Today we saw our first program designing tool, that is algorithm. We saw some examples of algorithm writing. In next session we will continue with flowchart and pseudocode. So that's all for today's session. Stay connected till the end of the course. Thank you.